We've arrived at the golden strategy of the bridge 10 to subtract strategy. This is the Achilles heel of a lot of our students, particularly our upper elementary students, who have not developed any efficient strategies for subtraction. So in the context, let's say, of a division problem and they're subtracting, they count on their fingers when we have teen numbers take away a number. And I think the key to that is just working on these bridge 10 strategy within these basic facts so we can get them much more fluent being able to do this, so that when they have the more complicated computations, they're not counting on fingers, which is very inefficient and slows them down. So to begin exploring this then, we can be using, of course, cubes on let's say 10 frames. I do like the structure of these 10 and 20 frames to be able to see what's happening. But in this example here, we're having, let's say we're doing 12, and we're going to take away 8. Now, if I'm going to be taking away 8 from these 12, I'm able to just take them one by one, right? So 1, 2, 3, 4, 5, 6, 7, 8, and I'm left with my 4, right? So that certainly is a way we're going to be counting back by ones, and this is the way most students do that when they are given that kind of a problem. So, but let's think about it in a couple of different ways. So if I have my 12 minus 8 here. Oops, 12 minus 8. Okay, so what if I were to think about taking away that 8 in 2 chunks? So if students like this thought about taking away for subtraction, we can take it away in 2 chunks. We can start with our 12. What if I took away 2 right in one jump? So I know that 12 take away 2, I'm at my 10, right? Now in that 8 then, I've got a 6 and the 2. So I've already taken away 2 of my 8. Now I need to take away 6 of my 8. And taking away 6 of the 8 must leave the 4, because I know 10 take away the 6 leaves the 4. So my thinking would be, well, to take away 8, rather than counting back by ones, let me count back in 2 chunks. Take away 2 of the 8, because it's just 2 away from 10 at 12. Then I have to take away 6 more from the 10, and I land on my 4. So being able to think about it in that kind of a way. And then I've got some other tools here that help us think of it in another way. So let's say that we're doing the problem 13 minus 8 here. Let's do 13 minus 8 again. So again, when students see that in the context of any kind of subtraction problem, or when you're doing it within division, they tend to want to count back by 1, so they'll count back the 8. But they're doing it on their fingers. It's very easy to make a mistake when doing that, and of course, it's slowing them down. So what if we were to take it away into 2 chunks? I know that 13 is 3 away from 10. So if I take away 3, I'm at my 10. Now, if I know my decomposition of all my numbers up to 10, I will know that an 8 is made up of a 5 and a 3. So if I've already taken away 3 of my 8 and I'm on 10, I have only 5 more to take away. And 10 minus 5 equals the 5, which is going to be, of course, our answer for the difference. So that's one way of thinking about it. If the kids want to be thinking about taking it away, which is a lot of how they thought about with subtraction, they can take it away in 2 chunks, but by bridging the 10. But what if we were to think of it in another way? What if I had a comparison type problem type, where I would say to you that you have 13 cookies and I have 8. How many more do I need to be the same as you? I'm still finding the difference, but I'm actually thinking additively. I'm thinking, what can I add to the 8 to make the 13? Well, if I want to think about that way, I certainly could count up by ones, and I would get my 5. But a more efficient way is to use my 10 as my bridge. So if I can think 8 plus 2 makes the 10, now I have 3 more to go to get to the 13, which means that it must be a total of a 5. Now, this is getting to the distance between the 8 and the 13. This is the understanding of subtraction as being a difference and that distance between the 2 numbers. This will serve them really well when we're trying to do mental math strategies with double-digit numbers, triple-digit numbers, and even decimals and fractions. It'll change the way kids think about it, and we're not going to get lost in all our procedures and things. So the idea, again, I'm bridging my 10, and I'm thinking additively. I'm thinking of that distance between 8 and 13. I know it's 2 more to get to 10, 3 more to get to the 13. Now, if students want to think about that in subtractive way, they certainly can. That I have my 13 and my 8, and I know, thinking subtractively, that 13 is 3 away from 10, and it takes 2 more to get to the 8, which is why it is the total of that 5. That distance between the 8 and the 13 is the 5. Now, certainly, if students know that 8 plus 5 is a 13, and they've been all along relating their addition and subtraction, they would know automatically that the answer must be the 5. If I know that an 8 and a 5 make a 13. Then 13 take away the 8 must leave me the 5, and 13 take away the 5 must leave me the 8. So it's being able to think of all those different ways, and different numbers different numbers lend themselves to more efficient strategies than others. So we want to be able to have that flexibility of thought. So let me just show you an example here of how we can take this to the representational. I love this tool particularly for the Bridge 10 strategy. It allows me to see it in a linear way. Of course, it's a Rekenrek, and I have my 20 beads. These are color-coded every 10. Let's say I want to take away 15 minus 8. Now, I can slide that over. Students at the start might want to count them up by ones, but I like to encourage them to do efficient slides. So there's 10. And there's 5 more. So I have my 15. And I want to take away the 8. Now, at first, they may want to take away it one by one. And we need to let them do that. That's developmentally where they are. We want to move them to, let's take it away in 2 chunks. How many do I know it is from 15 to 10? Well, it's 5. So taking away 5 right now, I'm already at my 10, but I have 3 more to go. If I know I can decompose my 8 into 5 and 3, I have 3 more to take away, and I don't have to count these, because I know 7 and 3 make a 10. I'm seeing my 3 here. I know it must be 7. I don't need to count that. I can trust that using my my addition of 10 facts. So a lot of foundational strategies going on here. The numbers, the pairs of numbers that make 10s, the decomposition of our numbers, and the idea that 10 and a teen number has that amount that in that ones position that's above it. So that's one way of thinking about it, taking it away. Now, what if we did the distance between the two? So here I have my 8 beads, and again, I know that because 8 and 2 make a 10. I didn't have to count those out. So if I have 8 beads here, it's 2 more to make 10 and 5 more to make the 15. So that distance must be a 7. So 8 plus the 7 must be the 15. I can think about that subtractively. Some students I know like to do that. So if I have a 15 to an 8, it takes me 5 to get to the 10, 2 more to get to the 8. So that distance is 7. Now, other students can be using other strategies as well. Some students I've met will know that 7 and 7 is a 14, so 7 and 8 must make a 15 for sure. But this bridge 10 strategy is allowing us to work in jumps using that 10 as a bridge. So if I were to record that, let's say on an open number line, if I have my 15 and I'm taking away 8, if I take away 5 first, I know I'm on 10. I have 3 more to take away in order to take away 8. I'm landing on my 7, and that must be my answer. Now, another way of thinking about it is the distance between the 8 and the 15. And I can think additively if I'd like to, but use my 10 as my bridge so I can do it in chunks. 8 plus 2 makes 10. 10 plus 5 makes a 15. This now is my answer, the distance between the two. So again, lots of different ways of thinking about it, but it will help that flexibility of thought. I want all kids to have all those tools in their toolbox. If I constantly only think of it in one way, some mental math strategies with larger numbers down the road and with fractions and decimals will be a lot less efficient. I want to have both tools in my toolbox so that I can be thinking either way it's most efficient with the numbers that I'm given. So super, super powerful strategy.